Hello, I've got a great one for you today. We're going to be taking a look at the EITS GT500. Let's jump right into the specs and a little bit of explanation of what this channel is. So this is the EITS GT500. There's the size. It's a almost $80, $79 cooling tray for your laptop. 5,000 RPM. It has a USB hub, and there are versions that both have the hub and without, but those RPMs do vary. The one I chose has the highest RPM, and it comes in either has a USB hub or USB hub with RGB lighting, height adjustable, and a 1-year warranty. Now, if you're just joining this channel for the very first time, I am data focused, so there are going to be lots of graphs. If you got any confusion about what I'm covering on any of the graphs, ask away. I'm here to answer them. This is sort of a new format for me, so I'm giving it my best go. So if you got constructive criticism, way I can improve it more entertaining, go ahead and leave that kind of comment down below. But I am talking constructive. If you're just going to rant and rave, don't need to hear about it. Now, as I go through it, I'm going to be filling out these the raw data for these different graphs. So I've already done it, the laptop just sitting on the desk. I've had it on a stand that has no extra cooling behind it. It is literally just a two-legged stand that allows for airflow underneath it. The EITS GT300 and the EITS GT500, and of course the three laptops and the tests that were done in performing. So this gives you a broad overview. Let's jump into the graphs for more specifics. This is a meet the laptops for the testing for each of the cooling pads I'm going to be going over. So let's start from right to left. The first laptop is the Asus U303 ZenBook. It is quite an old machine by today's standards. Now it does have a 4th gen Intel dual core pulling a maximum of 15 watts, and its GPU is the M840, and that can pull 30 watts. So that's 45 watts total in this package. Now the reason for it, using this in the testing and why it's valid, is it's got an aluminum body, and I don't know if you can see it in there, but there's a little bit of gray in there where I attached some thermal pads to the heat pipes and attached it to the bottom of the chassis so that there's extra heat dissipation. So this would be a test applicable to, let's say, MacBook Air, if you did that mod to it, or another laptop that you're applying this mod to where you're just attaching thermal pads to the bottom of it. Now, I do want to note that you would not do this on a laptop that you plan to use as a laptop. It would be to be used as a desktop replacement, because you're sinking extra heat to the bottom of the chassis, and most of the modern laptops have thermal sensors for the bottom of the chassis that keep them from getting too warm, to keep them from burning you. So literally, in order for this method to work, you probably would need a cooling pad of some kind, or using it on a stand with probably air blowing behind it to give it that active cooling. The second laptop here is my Lenovo Yoga C940, and it features Intel Iris G7 graphics before the Xe cores came about. It's got a, 10th gen quad core, the 1067, something like that, 65 G7. So big, large vent in it. A lot of the newer ones have an even larger vent, but this is representative of a metal bottom, no mods, integrated graphics, maximum power draw like around 65 watts, steady state around 45 watts. So it has a good representation for sort of your average everyday type laptops, or maybe lower end, lower heat use case, dual heat pipe, dual fan, that sort of thing. And the last laptop in the testing is my 2021 Zephyrus G15 G503, if I do recall the model correctly. And this laptop has 2 large vents, like 5 or 6 heat pipes, I forget the exact orientation. Bottom chassis is plastic, so this is representative of your mid-range standard kind of laptops. Plastic bottom chassis, grills to allow the vents to air to escape out the sides and out the back towards the screen, but not a metal bottom chassis. So the other two give us that metal bottom and those effects, while this would be that plastic, and I keep reiterating that. So that's the 3 machines that I'm going to be using for this testing. So modded with a metal bottom, plastic bottom gaming laptop, and an unmodded metal bottom laptop. And, well, hope you enjoy. Let's do a brief overlook at the EITS GT500. So it comes with this rubber or foam rubber inserts that this kind of can be slid into place. I think I have that backwards. To allow it to seal to whatever size laptop you have. So I ended up doing all my testing with just the biggest one, my 13, actually the really chassis is more like a 14-inch in size. Fit basically perfectly in here, and the 15-inch did as well. You can, it's got a magnet on the back for this side, so that works well. The disadvantage with foam is it does wear out and can break down. So I don't know how long this will last. Come around to the back and the bottom. You've got a little bit of a filter right here for the fan intake, which is right on the bottom. It's got some feet right here. You just can slide into place for whatever stand orientation you like. So basically, if you're using this, you're using your laptop like a desktop replacement, just hands down, that's what you're going to be using it for. You're not going to be typing with your laptop sitting on top of this. It's far too thick for that. On the left side here, you have a power button, and it uses a specific wall plug. This does not plug into your laptop like their GT300. And you've got a little scroll wheel here for what airspeed you want with it all the way this way, so low. It does turn off the fan. Big old fan right there in the middle. This housing does not come off. So I wouldn't mess with that at all. And on the right side here, this is all USB 2, and it does use USB-C to plug in, but these are USB 2 speeds. I plugged in an external NVMe SSD, and I got 30 megabytes per second. So perfect for keyboards, wireless, whatever, but you're not going to be transferring data with it. So I don't know, considering its price tag, these should just be USB 3, at least 5 gig per second. You don't even need to include 10 gig, just 5 gig would be sufficient. But oh well, that's what they did. So value proposition here is a little bit lower than I would like it to be. Very plasticky, very light for its $100 plus price tag. So that's a little bit disappointing. It picks up grease on it pretty easily, as you can see the shine on the bottom. All right, so the accessories, the power cord, and the USB cable, they just came right in there. And it comes with this extra piece of foam. I don't know why, but it came with it installed right in the middle. I'm not sure who would use the stand like this, but it comes with it. First up in testing is my laptop, the Yoga C940. So the GT500 allows the CPU to run at a higher clock speed for longer with none of that thermal throttling that we're seeing when it's on both the stand and on the desk. And when we take a look at the temperatures, again, this is for a CPU test only for the R23. The temperature, while isn't lower, is more stabilized with the GT500. Mind the tests, the first time I ran through it, I didn't let it hit the thermal max, so tau, so when I took the section cut, I actually took it after the 1 minute mark. But adding additional cooling obviously has a benefit to this laptop. And when we take a look at the CPU wattage, obviously the CPU is able to draw more wattage. The thermal design on that laptop doesn't quite live up to, I guess you could say, expectations. So if your laptop is like this, you could see a benefit by adding a cooling pad to your, well, overall setup. Now for some simplified graphs, because I know those other ones were time charts. So we got CPU only, temperatures, and you know, there's not much temperature difference. I mean, obviously there's an improvement in temperature max, but in average temperature, not really with what we're seeing. Now, when we take a look at clock speed, obviously there's a benefit from 2,300, I'm rounding it down to 2,800. So there's obviously some benefit, but how much benefit you're actually going to see could vary from one laptop to another. Obviously having more cores does increase that benefit more greatly. And then a delta T from with the laptop sitting on the desktop to it on whatever extra cooling device it was sitting on. So now to really stress the system, I ran R23 and FireStrike. So I was stressing both the CPU and the GPU of this poor laptop at the same time. That obviously causes it to run hot. So we got the CPU average clock speed flatline slightly higher than when it's on a stand or sitting on the desktop. So there's an improvement. How about for the GPU? Well, the GPU is running a little bit better. So let's keep things moving. Let's take a look at the wattages that were being drawn. Well, there's obviously an improvement in the package power for sitting on the stand for both the CPU and the GPU. Now, how about in terms of temperatures? Well, this gray line does belong to the table. So that's the peak. And when we add the stand, there's a little bit lower temperatures. And this orange line, actually that's the table. And when we take a look at this yellow line, that is on the stand. While down here, we got the pink, and we got this kind of, I don't know, brown-orange. And those are the two temperatures where it's on the GT500. So that is a significant drop in temperature. Now, it does get there eventually, but in that time, if we jump back to some of these other ones, we're losing wattage, so we're losing clocks on the table and on the stand. So there's obviously a benefit to adding extra cooling to this laptop. And once again, simplified view, GPU clock, CPU clock, GPU clock, average. And on here, we have the name of the device that was sitting on, so desktop, stand, and GT500, the noise level that I recorded while doing the test, the R23 score, the CPU wattage, average, frames per second, average, and GPU wattage, average. So right away, there's an obvious improvement in frames per second in the FireStrike score, even though the wattages are all the same. So lower temperature means that it can run more efficiently, so that's a plausible explanation there. Same with the CPU. Also, this is an average wattage, not peak, so take that with a little bit of a grain of salt. And obviously a small improvement in the CPU clock speed. Really hard to notice while running this because it really just bogged down the system because it was running flat out, and it's a poor 4-core with integrated graphics. And we got the clock speeds over there. So let's keep this moving. And the temperatures. So in the yellow, we got the GT500. In the orange, we got it on the stand. And on the blue, it's on the desk. So obviously an improvement in temperature running this test, where if you're hitting it as hard as possible, you're going to get the greatest temperature differential, but you're paying for it with, let's see, from 38 decibels to 64. Every 10 decibels is a doubling in noise volume approximately. So that's almost 4 times as loud. If you have a roommate and you're in a dorm room, you're going to be annoying them unless both of you are wearing headphones. So, you know, take this with some semblance of idea. And then the delta T for this test, hitting the CPU and the GPU at the same time. And this is based still with the desktop as the baseline. So this is temperature improvement from sitting on the desk. Now onto the second laptop I tested, the ZenBook U303, or is it UX? I don't remember. Either way, 303. This has a low-powered dedicated GPU as well as a dual core. But really what matters is what kind of wattage is. So it's a total system package power of like 45 watts. And I added extra thermal pads that are used for like GPUs that sink extra heat into the chassis. We do see no improvement in wattage that the CPU draws. How about in terms of clock speed? Well, slight improvement, average I would say, but also the dips are lower, so I'm going to wash that up to kind of equivalent. And we got the GPU, which did absolutely nothing to it. So this is a little older device, so maybe things have changed, but it still gives you an idea of how much improvement you would see by sinking extra heat into your chassis and then cooling it. So FireStrike and R23 CPU and GPU. The blue lines are on the table, the orange and yellow line are on the stand, and the pink and this, I don't know, off pinkish orange color are that. So there's obviously a huge improvement by adding extra cooling. How about in terms of clock speeds? Well, once again, noise measurement, the test, the R23 score, and the frames per second. So there's a small improvement in the R23 score. On average, I ran it through a couple passes. And all right, the temperatures that I saw, once again, we got the different colors for each of the different tests. Down here, the GT500 is the yellowish one, while the orange here in the middle is on the stand and the blue on the bottom is on the desk. So there's a very significant change in temperature. And the delta temperature going on over here, with the top bars being for the GT500, the bottom being for on the stand. So a 23-degree difference in the CPU. That is a huge improvement. And in the FireStrike test, I didn't include any graphs for it on this one because the frames per second are all identical. There was some improvement or actually no improvement, actually a small loss in physics FPS with the extra cooling, run-to-run variance. It's well within run-to-run variance, not a deal. GPU score, or GPU test 1 frames per second, GPS test 2 frames per second, all within margin of error. Last laptop is the Zephyrus G15 G503, if I recall the name correctly. Either way, it's like 2021 edition with a RTX 3070. Okay, table, stand, GT500, and the GT500 allows the clock to run a little bit higher. If we take a look at the GPU is obviously running a little bit higher. So let's keep things moving. How about temperatures? We have the GPU and the CPU up here. And when you add the extra cooling, they drop significantly and are way down here. So obviously a huge improvement in adding the extra cooling to this laptop. How about in terms of power draw? Flat line, no change. Let's keep moving. All right, average clock speeds in the CPU and the GPU. All right, once again, the naming, noise, R23 score, the wattage of the CPU, the frames per second I saw, and the GPU wattage. Not much difference. The scores were kind of random. I'm not too concerned that on the GT500 the score is a little bit less, because run-to-run variance, I saw it swing to the same level, and sometimes I saw them swing lower, just how the average ran in 3 cycles that I did it. Okay, so the CPU clock speed on average ran a little bit higher with the extra cooling, as well as the GPU, but notice it's not significant. You're probably never going to notice it in any sort of gaming. Okay, temperatures that we saw. Well, there's obviously an improvement in GPU average temperature as well as max, and CPU average temperature as well as max on all these tests, but it's also really loud. Very loud. Unpleasantly loud. Do I need to reiterate how many times how loud it was? Because my headphones, I still found it unpleasant. But obviously, a 12-degree difference versus having it sitting on the desk. But no meaningful performance difference compared to just putting it on a stand. Okay, let's do the next test. Tomb Raider frequency. Well, the CPU clock speed was running a little bit higher. The GPU clock speed, about equivalent. Going to how much power was being drawn. Well, interestingly, the GPU was drawing slightly less power than the other tests, and the CPU was drawing slightly more power than the other tests. But I ended up with the same average FPS across the Tomb Raider test, between 103 and 104 FPS. Okay, Tomb Raider thermals. So obviously, huge benefit by adding the cooling. Simplified view, bar graphs, GPU average temperature, big improvement. Max temperature, big improvement. CPU, again, improvement. Average FPS, no difference. 1 FPS you're not going to notice. Okay, so delta T, 12 degrees for the GPU, 9 degrees for the CPU, but at from 46 to 64 decibels. Yikes. I mean, that is 64 decibels is unpleasantly loud. 46 decibels is already kind of annoying. So I'm going to iterate this throughout this review. Okay, FireStrike. No meaningful difference. The trends are all looking the same. Okay. By the way, this was frequency versus time. Okay, wattages, average wattages. Okay, they look about the same. Let's continue going. Okay, thermals. Well, obviously there's an improvement in temperatures. Okay, let's take a look at the simplified view. Well, in 3D Mark FireStrike, the combined FPS, well, there's a slight improvement in FPS overall in the CPU and the GPU by adding the extra cooling, because it allows the temperatures of the system to drop. That allows for better spiking behavior of the GPU and the CPU when running it in a benchmark type scenario that you're not going to notice in game. So it's like a false positive, if you will, that we're seeing an improvement that doesn't really exist, and the improvement is actually only like 1 to 2 FPS. So you're not going to actually notice it when you're really gaming, like we saw in the Tomb Raider test. We didn't see any temperature differences, really. And that brings us to the end of the video, where these are the delta T's for the one test that all these laptops have in common, and that's running the Firmark with the Cinebench R23 and the temperature improvements that we saw. So the Zephyrus G15 saw, let's say, a 11.5 degree difference reduction as opposed to sitting on the desk. The ZenBook U303 saw a 23 degree difference, or we could say like 21.5, whatever. That's a huge improvement. The Yoga saw, let's say, a 13 degree difference, very in line with what we saw at the ZenBook. So depending on what kind of machine you're running, you can see a huge improvement, or actually a huge improvement or an epic improvement. But the main takeaway is that I want to iterate is just buying a stand might do it for you. Once again, if you've got suggestions for this type of video, what you'd like to see improve, change, whatever with the graphs, how it's presented, please leave that in the comment section below. I'm happy to kind of alter it. Normally I do PC fans and how they operate, so this is kind of a new thing for me. Anyways, I've really enjoyed doing this kind of testing because I kind of wondered how much improvement in performance that they actually offer. If you like this kind of content, please hit that subscribe button. And not everybody has the capability, but if you like what this channel is, like where it's going, and would like to help support it to make it grow and get better, please think about joining me as a Patreon or as a YouTube member. It really does go a long way in helping support this channel, because right now it's completely unsponsored, which means it's me spending my own money. And money does not grow on trees, I guess. Anyways, and I know it doesn't for you as well, which is why I said if you have the capability. I understand that every situation is different, so just hitting the subscribe button really does go a long way in helping this channel gain traction to get YouTube support. Anyways, have a great day. Hope to see you next time here on Computer Tech and More.